How to accurately size components for buck boost choppers. Imagine you have a solar panel or a battery source with a voltage that keeps changing. You want to connect it to a load or the grid smoothly. That's where buck boost choppers, or converters, come into play. They help manage voltage variations efficiently. But to do that well, you need to pick the right components. Let's walk through how to size each part accurately for reliable and efficient operation. First, you need to know your key parameters. Find out the lowest and highest input voltages your system might see. Also, determine your desired output voltage, the maximum load current, and the switching frequency you plan to use. These numbers are the foundation for everything that follows. Next, calculate the duty cycle. This is the ratio of the on time of the switch to the total switching period. For a buck boost converter operating in continuous conduction mode, use this formula. Duty cycle equals the output voltage divided by the sum of input and output voltages. This tells you how long your switch stays on during each cycle. Now, select the inductor. The inductor stores energy and transfers it to the load. Its value depends on the ripple current you want and the switching frequency. Use this formula. Inductance equals the input voltage times the duty cycle, divided by the ripple current times the switching frequency. Keep the ripple current between 20 and 40% of your maximum load current for best results. Moving on to capacitors, both input and output. They smooth out voltage fluctuations. To size the output capacitor, divide the ripple current by 8 times the switching frequency times the maximum allowable output voltage ripple. The input capacitor is chosen similarly, based on input voltage ripple. Proper capacitor sizing helps keep your voltage stable and your system efficient. Choosing the switching device is next. Use a metal oxide semiconductor field effect transistor that can handle the maximum input voltage and peak current. The peak current through the switch is the maximum load current plus half the ripple current. Make sure the device has low on resistance to reduce power losses. Don't forget the diode if your design requires one. It must withstand the maximum reverse voltage, which is roughly the sum of the input and output voltages. Pick a diode with a fast recovery time to minimize switching losses, especially in high-frequency applications. Finally, set your output voltage with a feedback network. Use a resistor divider connected to the feedback pin of your controller. The output voltage equals the reference voltage times 1 plus the ratio of the two resistors. Use resistors with tight tolerance, like 1%, to keep your voltage regulation accurate. Remember to consider practical factors too. Ensure all components can handle the maximum temperatures and currents. Use heatsinks on power devices and plan your PCB layout carefully to minimize losses and electromagnetic interference. Proper component sizing in a buck boost converter ensures your system runs smoothly, especially in renewable energy setups where input voltages can change a lot. Following these steps with precise calculations will help you build a reliable, efficient power system that can handle real-world conditions with ease.